Hello, curious students. Today we are going to dive into the fascinating world of conductivity. We will learn that conductivity means and how different materials allow heat or electricity to pass through them. We will discover which materials are good conductors and which are insulators, and we will see examples from everyday life. So let's get started. So make sure you have the following. Let's start from learning objective. We have to understand how does mass affect the change in temperature of a substance, explain how does the type of matter affect the change in temperature, and analyze what other properties affect thermal energy. Let's go to vocabulary now. So we'll speak about thermal energy, boiling temperature, directly and inversely proportional. What's the meaning of directly? So this one is directly and this one is inversely proportional. Aluminium, which is Al, specific heat, PSC, or the amount of heat to increase 1 gram by 1 degree Celsius. Also, we speak about thermal conductor and what material like this. Also, we speak about insulator, kinetic energy, reflectivity, absorbency, thickness, surface area, and finally environment. So make sure you know all of these words before started. So if we have two beakers here, it's an example for thermal energy and temperature. Beaker X and beaker Y. This is beaker X and this one is beaker Y. So beaker X 50 ml and beaker Y 100 ml, both of them at the same temperature. So which one has more thermal energy? We can say beaker Y has more thermal energy because it has more mass or more molecules. Here we have 100 ml and here we have 50 ml. Another example, if we take two beakers with the same mass, same number of molecules, but one of them at 25 degrees Celsius and the other one at 5 Celsius. So we can see beaker Y more thermal energy because it has higher temperature, but we have the same number. Okay, here we have a question for discussion. So why is kitchenware made out of so many different materials? Why it's made from stainless, wood, different materials? Why glass? So let's figure out. So examine the figure of the pots on the right. Okay, look here. Will the water filling each pot boil at the same time? So all of them will boil at the same time if the energy in the same of each burner. So we can find the smaller pot would get hot faster. This one will heat faster because there are few particles, only few particles to uh, transfer. Okay, we had this experiment and we did it in laboratory, and make sure that you measure these things: mass and initial final temperature. So mass is one factor that determines the amount of thermal energy in a substance. It takes more energy from the surrounding to increase the kinetic energy of the particles. So if the mass increases, the change in temperature will decrease. So this is inversely proportional. So the change in temperature and the mass. So we are speaking about change in temperature, T final minus T initial. So if the change if decrease, the mass increase. So here we can see this figure for directly proportional and the other one is inversely proportional. Directly proportional means if someone increase, the other one will increase, but inversely, if one material increase, the other one will decrease, like change in temperature and mass. Maybe he asked you about this. So which one is the fastest to heat up? A small pot of water or large one? So it's clearly the small pot. Uh, it increases because it has less mass. Okay, here another example of metals. So metals they used for pens because they conduct thermal energy well. So it conduct thermal energy well. So cotton or silicon is an example. They used for mats because they are do not conduct thermal energy well. So we use it because they do not conduct well. So if we look here, now let's speak about specific heat. So how much it take time to rise the temperature? For example, if we have two different materials, okay? If we have two different materials, for example, if we have water and sand, okay? Both of them take the sun from for the same amount, but after maybe a specific time or 2 hours, if you feel sand, you will feel it hotter than water. Why? Because the specific heat of sand less than specific heat of water. So the meaning of specific heat are like how much it takes to rise the temperature of the substance. So if we want to read the definition for specific heat is the amount of thermal energy required to rise or increase the temperature of 1 kilogram by 1 degree Celsius. So this is the definition of specific heat. Here we have also another example of specific heat. Here we have two pans, one made of iron and the other one is earthen pot. So we can see the iron heat fastest, so easy to warm up. This one hard to warm up. That's mean it has more specific heat. Okay, more specific heat. Okay, so let's keep going. Now we can compare the different specific heat for some materials. As we can see, the greatest one is water. This is liquid water, and this one has high specific heat. Okay, high specific heat. But the lowest specific heat here, as we can see, it's copper, which is Cu. This one is the smallest specific heat, so we can increase the temperature of copper in a few seconds. Okay, so here we have an question. So which pot heats up easily? You have to match them. So please look at the value of specific heat, okay, for both of them. So this one is higher specific heat, so it take a lot of time to heat up. So this one does not heat up easily, this one with a lowest specific heat. Okay, so as I said, if we have sun here, okay, and sand take the sunlight and radiation, and water also, so both of them take the sun light at the same amount and same time, but we can see sand gets warmer than water. Okay, that's mean the sand has lowest specific heat than water. Also, we have another example here for specific heat. So we have water and sand. Here we have small temperature rises for water, and here we have high temperature rises. That's mean water has high specific heat. Okay, so the relationship between temperature rises and specific heat is inversely proportional. Here also I have another example. So you can bake a food in either a metal pan or oven safe glass. So here we have metal pan and oven safe glass. So we require more energy to heat up. So glass, the question told you, is require more energy. That means the glass has high specific heat. Okay? Specific heat. Okay? High specific heat. Okay. So this one has high specific heat, but the metal has the low specific heat. So which would cool down fastest? So this one will heat fastest and cool fastest. So explain your reason. So we can say a glass require more energy to heat up because it has specific heat, but the metal pan we think will cool fastest because uh, it has a low specific heat. Okay, so if we have this question say which car will be warmer and why. So think about this and give me the answers. So if we think about it, we can see this car reflect the sunlight. Okay, the other one absorb the sunlight. So I can see this car here will be warmer. Okay, why? Because it's absorb the heat energy from the sun. So if you wear this shirt, a black one and white one, we can see the black shirt reflect the sunlight. Okay, so this one will be colder, and the other one, the black one, will absorb sunlight or absorb heat from the sun, so it will be warmer. Okay, so if we want to speak about surface area, so the meaning of surface area is the amount of exposed outer area of a substance. So if we increase a surface area for a given volume, that's increase the energy transfer between the substance and the surrounding. For example, a shallow pool has more surface area than a deep one, so it will transfer more thermal energy to the surrounding. So the amount of energy needed to change the temperature of a matter sample by a given amount depends on first one, type of matter, size of sample, and environment. Okay, let's see an example. So, which students in the image gain most thermal energy? One of them wear a black shirt, and this girl wear a white shirt. So we know that white will reflect the heat from the sun, okay, and the black one will absorb. So we can give an answer like this: the student in black shirt will gain more thermal energy from the sun because black one or dark color absorb more energy than the light color or white color. Okay, so now we have to see some equations uh, for review. If we have different materials, let's see this question number 5. If we have different materials, okay, as we can see here, they have different value of specific heat. So firstly, you have to determine which one has the highest specific heat. We can see this one, aluminium, has a highest specific heat, but copper has the lowest one. So this one high specific heat, but copper has low specific heat. Okay, So I looked at the question. So let's read the question. Okay. So kitchenware company is looking for a market. They want to be able to say it heats up quickly. So which one will heat up quickly? We know that copper heats up quickly. Okay, and cools down quickly. Also copper heats up and cools down quickly because it has low specific heat. The material they narrowed it down: aluminium, copper, and glass. So which one will you choose? We can use copper would be the best choice. Why? Because it has a lowest specific heat. That means the copper will good conductor for thermal energy, and it will heat up quicker than other. Okay, so this is an example for specific heat. So in summary, uh, we have explored how conductivity shows us how well material can transfer heat or electricity. We learned that metals like copper and aluminium are great conductors, while materials like wood or rubber are insulators. This understanding helps us see how we use different materials in our daily lives, from cooking to electrical wires. Thank you for watching.